This is chapter 12, log and exponential expressions. For any positive number b and any positive real number x, the exponents that b must be raised in order to equal x is the log. So for example, log of 125 base 5 equals 3 because 5 to the third equal 123. And so b is 5 and x is 125. So x is the log or the exponent. So the 3 is the exponent. It is the log of 125 of the base 5. Now, we have the exponential and the log form of an equation. And so b to the y equal n. Remember, the exponent y is the log. And so b to the y equal n is the same thing as saying log of n base b equal y. So for example, if I have 2x plus 7 equal 25, first let's subtract the 7. And so 2x equal 18. Now remember, x is the log of the base 2, and so x is equal log of 18 base 2. Now, let's start with the log. So we have the log of x minus 7 base 3 plus 2 equals 6. Subtract the 2. And so we have now the log of x minus 7 base 3 equal 4. Once again, the 4 is the log, which is the exponent of the base b, which is 3 in this case. And so 3 to 4 equal x minus 7. Remember, the exponent 4 is the log. So therefore, the log of x minus 7 equal 4. Now, let's look at the product rule for the logs. And so we have the log x plus the log y. They have the same base b. And so we can just say that we have one log of base b, and then we just take the x times the y. For example, the log of 5 base 2 plus the log of x base 2. We can use the product rule, saying that I have 5 times x of 1 log base 2. Another example, log of 7a and b. 7ab means you take 7 times a times b. So therefore, the log of 7ab is the log of 7 plus the log of a plus the log of b. Another rule, quotient rule. Now, the log of x minus the log of y, same base b, then it is the log of x over y, or x divided by y, base b. The key is they must have the same base b. So for example, log of x base 4 minus log of 9 base 4, same base, therefore we can divide. And so it is the log 4, actually the log of x divided by 9 base 4. Another rule, which is the power rule. And so if I have the log of base b of x to the power r, therefore we have the power rule. So we take the r, which is the power, times the log. So this case, the log of x to the r of base b is r times the log of x base b. So for example, the log of x to the 8 base 7, that is 8 times the log of x base 7. Now what about this? 13 ln a. ln is a log, and so 13 ln a means that 13 times the log of a. And so we use the power rule backward. So the 13 now goes back to be the exponents. And so 13 times ln a is then ln of base, actually ln of a to the 13. Now let's put them together. So we have 8 log of x base b plus 5 log of y base b minus 2 log of z base b. Now we want to use our rule one at a time. Now let's move the 8 back to the power of x. Now this case we use the power rule. We do the same thing with the 5 and the negative 2, actually just the 2. And so 5 now becomes the power of the y. The 2 becomes the power of the z. So we have the z squared and the y to the 5th. Now they have the same base, b, and so the sum, that will be the product of x to the 8 times y to the 5th minus will become the division. So that's why z squared is in the bottom. And so together we write as a single log. Now let's go backward again. What about this? The log of a to the 7 over b to the 6 times c to the 5th. Now let's expand this log. And so we could use the quotient rule. Now notice that the product in the denominator must be negative. And so we have the log of a to the 7 over b to the 6 times c to the 5th is then the log of a to the 7 minus the log of b to the 6 minus the log of c to the 5th. And now we use the power rule now. So 7 comes out. So 7 times the log of a. The same thing happened with the 6 and the 5. And so the 6 comes out. And also the 5th comes out. So therefore, we have 7 log a minus 6 log b minus 5 log c. And we're done.